My name is Mdleko Lebohang, and today we're going to be doing mechanical technology pedagogy, a lesson which undergoes the topic joining methods and process. So firstly, we're going to define joining methods as techniques or materials used to join two or more materials classified as temporary, permanent, or semi-permanent mechanical joining fusions. And then forces are vector quantities which include direction and magnitude. So here we're going to be looking at the types of joining methods, which we have permanent joining method, semi-permanent, and temporary joining method. In permanent joining methods, the permanent joints are not being able to be separated because they can cause permanent damage or destroying the joints itself or the parts, which the joining methods can. The example of the joining methods are welding, brazing, soldering, and so on and so on. Good morning everyone, my name is Mdleko Lebohang, and today we're going to be learning about joining methods and forces at mechanical technology grade 11. So firstly we're going to define joining methods, which are techniques used to connect two or more materials classified as temporary or permanent, mechanical or fusion based depending on the application and material properties. And forces are anything that can cause change to an object or a vector quantity that includes both magnitude and direction. So now we're going to look at the different types of joining methods. We have three different types of joining methods, which are permanent joints, semi-permanent joints, and temporary joints. First of all, we're going to be looking at the permanent joints, which are joints that cannot be separated without damaging or destroying parts of the joint itself, which we have examples of permanent joints, which are welding, brazing, soldering, adhesive bonding. Next, we're going to be looking at semi-permanent and temporary joints methods. Semi-permanent joints allow for dismantling without destroying parts, but the joining components itself usually has to be replaced or deformed to remain, which are rivets, pins, and split pins. Temporary joints hold parts together securely but are designed to be easily assembled and disassembled without damaging components, which are bolts and nuts, screws, keys, and keyways. So next we're going to be looking at forces. We have formulas which show how some of the forces are being calculated. First of all, we have the weight, which can be represented as Fg, which is equals to mg, whereby you have to be given mass so that the gravitational constant is 9.8, which can be multiplied by 8. And then we have friction, which it is calculated with the coefficient of the friction and the normal force. And then we have the Newton's laws, which are F net is equals to 0, F net is equals to ma. And we have three different types of forces. We have contact forces, non-contact forces, and resolving forces. In the contact forces, we have applied force, normal force, friction force, and tension force and resultant force. In the non-contact forces, we have gravitational force, magnetic force, and electrostatic force, whereby the gravitational force is an attractive force exerted by Earth, whereby it's always going downwards. A magnetic force, the push or pull exerted magnets on magnetic materials. And then the electrostatic force is the attractive or repulsive force between electrical charges particles. Next, we're going to be moving to the resolving forces, the perpendicular components, which are x and y components, and we have the equilibrium, which is the sum of forces equals to 0. Excuse me. Okay, here we're given an example of a dog which is pulled in an incline by a rope. Okay, here on we're going to be calculating the component. Therefore, we have the x component and the y component. Therefore, it's given by sine of, the given force is 60 newtons, whereby we'll be given a sine of 40. The angle given is 40 degrees, whereby we're going to use the horizontal and vertical component formulas, which are the horizontal component is f cos of theta and the vertical component is f sine of theta. So we're going to first calculate the f component, the vertical component, which is equals to 60 sine of theta, and then we'll be given the answer on that's how we calculate the component, the vertical component. Then the horizontal component is calculated by f cos of theta. Therefore, you're gonna punch in the calculator and get the answer. So moving forward, in the conclusion of what is being given on the slide, the importance of joining methods and forces in grade 11. It is important to know how joining methods and forces work for constructing safe structures and machines. It also highlights the ability and use of a certain machine and materials to use in a certain structure. They are very necessary because they dictate the structural integrity of assemblies, prevent structural failure, and allows most engineers to calculate accurate loads to be transferred from one component to another. And then we have reached the end of our slides. Thank you.